up until this point, there's only really 5 angles that we can get exact values for sine and cosine. 5 acute angles. There's these 3, and then using the sum, sine A plus B, cosine A plus B, we can get 75, and using sine A plus B, sine A minus B, I can get 15. But that is not very many, considering there's 89 angles, or 90, or 89 between 0 and 90, maybe 88 if you count just the integers between 1 and 89. So getting the exact value of sine 18 is not going to happen through sum and double angles, or half angles really didn't get us much of anything except for things like 22.5 or things like that. We're going to have to get sine of 18 a different way, but once we have sine 18, an exact answer, and cosine 18, an exact answer, then we will be able to combine it together with these other things that we already have, like 15, and we'll be able to get all the way down to sine and cosine of 3 degrees, and actually any multiple of 3, 6 degrees, 9 degrees, and so on. So the key is going to be sine 18. With sine 18, I can get sine of 3 and cosine of 3. And with 3 degrees, I could use sine A plus B or double angle formulas, things like that, to get any multiple of 3. And that will increase our list from 5 things all the way up to about 30 or 29 things. And geometrically, the question is, if I have a right triangle that's 18, this is 72 degrees, and 90 degrees, and the hypotenuse is 1, what's the length of the side opposite the 18-degree angle? And the trick to this question is to draw a second 18, 72, 90 triangle. And then if I erase this line in the middle, I end up with an isosceles triangle that's known as the 36, 72, 72 isosceles triangle. It's an isosceles triangle, and it has a special property that no other isosceles triangle has, which is this. If I draw an angle bisector through one of these 72-degree angles, if I do that, if it's an angle bisector, these two angles will be equal to each other, so they'll both be 36 degrees. That makes this triangle here a 36, 36, that's 72, 108 degree isosceles triangle. This green triangle has a 36 degree angle in it, a 72, which makes this other thing 72. So this green triangle here is actually similar to the large blue triangle. Not only that, it's an isosceles triangle, so if this side over here is x, this side over here, really, can I call it 2x? Because x was actually just half of it. So that's 2x also. Now remember, the red triangle's isosceles, 36, 36. So if this is 2x, this thing here is also 2x, that piece. And since the whole thing was 1, this is going to be 1 minus 2x. So there's a lot of x's in here. There's a lot of isosceles triangles. What if I were to put the blue triangle and the green triangle side by side? What I would see is This is 1 minus 2x. This is 2x. In the blue triangle, the base is 2x, and the sides are 1. Now, because both of these are 36, 72, 72 triangles, they're similar triangles to each other, so I can set up a proportion. I'll just say 2x over 1 is equal to 1 minus 2x over 2x. And if I cross multiply, I'll just move it up here, I get 4x squared equals 1 minus 2x. And if I move everything over to one side, plus 2x minus 1, I end up with quadratic equation 4, 2, negative 1. So 4x squared plus 2x minus 1 equals 0. And if I do the quadratic formula, I get negative b plus, I'm not going to do plus and minus because the minus might end up negative, plus the square root of b squared minus 4 times 4 times negative 1 over 2 times 4. X equals minus 2. Yeah, I definitely want a plus here because if it's negative 2 minus, it's going to be negative. Well, of course, sine of 18 is going to be a positive number. So it's minus 2 plus the square root of 4 plus 16. This minus and minus becomes plus over 8 equals minus 2 plus square root of 20 over 8 equals minus 2 plus, I'm going to call this 2 root 5, change 20 to 4 times 5 over 8, which turns into minus 1 plus root 5 over 4. Minus 1 plus root 5 over 4 in the calculator is about 0.3090. And that is the exact value of sine of 18 degrees. So the answer to the question in the beginning was negative 1 plus square root of 5 over 4. With the sine of 18, it's possible to calculate out cosine 18. Maybe we say cosine 18, cosine squared 18 equals 1 minus sine squared 18. So cosine 18 is going to be the square root of 1 minus, now sine squared of 18 would be minus 1 plus square root of 5 over 4 squared. Pretty ugly expression. Maybe I can clean it up a little bit. 1 minus over 4 over 16, sorry. 1 minus 2 root 5 plus 5. Change this to 16 over 16, so 16. 1 plus 5 is 6. 16 minus 6 is 10. 10 minus 2 root 5 over 16. Can't do that much more. Reduce that fraction by dividing top and bottom by 2. Get 5 minus the square root of 5 minus root 5 over 8. You pop that into the calculator, you get 0.9511, which actually is the cosine of 18. That might be a nicer way to write this. The point is that with exact values for sine 18 and cosine 18, we'd be able to use the half angle formula and get 9 degrees, or we can do sine of a minus b or cosine A minus B to get 3 degrees. Can't get much better than 3 degrees, though, for exact values. Usually what they do, after they figure out what sine of 3 degrees is and what cosine of 3 degrees are, they use them to get sine of 1.5 degrees using the half angle formula. And then when they have that, they do the half angle formula again to get sine of 0.75 degrees. And then they kind of just find the number that's sort of between those to approximate to get sine of 1 degree. So they only do approximations for those. It's only multiples of 3 that we can get exact values for. Well, that's it. Now we have sine 18 degrees, which gives us the other values that we needed, the other 24 or so, to get exact values for all multiples of 3.